sure everybody's comfortable with this notation. I just became familiar with it not too long ago. I've seen it, I just never have used it in any of my problems. But this 32 that I'm circling right here, you can see where that comes from in this representation up here. You have 1, okay, and then you have 30 zeros and then these 2 extra digits. So this 30 and the 2 extra digits is the 32 that you see right here. In a similar fashion, you'll get the 62. Okay, the 62 comes just from examining this extra 29 digits, I guess, extra 30 digits, counting this 1. You do have to count this 1, so that explains why you had to move 30 over, okay? Anyway, this is just a nice way of representing a very large unpronounceable number. Now we're looking for a 2-digit number n such that x minus n is a perfect square. Now this may seem a little contrived. I got this from an SMO problem, and it's similar. I changed everything up a little bit. It was a multiple choice question there, so I had to adapt it just a little bit to fit. But I think it's kind of a nice problem. It's a little contrived, but hey, aren't they all? But y'all notice right here that this very first step was a tough step for me even, you know. Notice that the 32 here, okay, and we have 10 to the first right here, right? But I think a lot of you probably see why that happened. This is going to be in the form a squared. And this part right here is in the form, it can be molded into the form 2ab, I should say. All right, and we need to get a b squared to pop out of it and then adapt it or make it fit with this 81, okay? And that comes on the very next line right here. It actually works out pretty nicely. You can see exactly what happened down here. Let's see, where are we? Right here, yes, okay. Now, let me get this. Okay, so we wrote the 10 again, okay? And then we split it up into 2 times 5, as you can see right over here. So literally this would be your 2AB. And that's products, folks. It's the product. Okay, the little dot there means it's a product, so that's 2AB. Okay, now notice this would be your b squared for 5 squared, right? So this would be your b squared. It just works out. I mean, it all just kind of falls in pretty nicely now. Plus b squared. Okay, and then this, of course, is a squared right here. All right, but of course that has the form. A plus b quantity squared is equal to x, right? And so it's very clear here that we're just about done. We can just write down x minus 56 okay, is equal to a perfect square. Namely, namely, let me get some more space here. All right, so that would be, well, let's just copy it down. 10 to the 31st plus 5. And we would actually know what the square root was. Large number again, but no surprise there. Okay, so that means our n would be 56. Okay, that's final answer, and I guess we can come back up here and place it here if you want to. So your n, this n would be equal to 56. Now I know a lot of you probably just looked at this and knew the answer, but it's not quite as easy as just saying, oh, well, it has to end in 25, right? Because, for example, just an example problem, let's say 1, 0, 0, that's not a you can verify that this isn't a perfect square. So it's tempting to think that because it ends in 25, the whole thing might be a perfect square, and it is some of the time, like in the case we found, but this is an example of where this is not a perfect square, and so you actually have a little bit more work ahead of you. But anyway, I hope you enjoyed the problem.